Everyone, welcome to my channel Sai Gate Chemical. So today we will be discussing about the topic forced circulation evaporator. So the name itself we will be knowing that what is a forced circulation evaporator. So what is the meaning of an evaporator? So before going to the evaporator, what is the concept of the evaporation? So we will be having a solution. I am going to heat the solution. Your all the solvent will get vaporized. Okay, we will be having only solute. The concentration of the solute will be very weak. Okay, for increasing the concentration of the solid, we are using an equipment known as an evaporator. Okay, as per the previous topics, we have been discussed about the types of the evaporator. We'll be having general classification will be natural circulation evaporator and a forced circulation evaporator. So today we'll be discussing about the forced circulation evaporator. So that what is the name itself tells about that we are giving some force for circulating the component for increasing the concentration of your liquid. Okay, so what is the meaning of circulation? Means suppose if your outlet contains some amount of the liquid which is not concentrated, that can be recycled again for increasing your concentration, but this will not be happen in your natural circulation evaporator. Okay, so here the construction will be like heating element shell, vapor head, downtake pipe, circulating pump, deflector, steam baffle, non-condensed gas outlet, condensate outlet, cyclone separator, and liquid level indicator. Okay, so these are the components which is present in your forced circulation evaporator. Now coming to the working, see, as we discuss about that, what is the force? So we are giving some force by some devices. So here we are using the pump for forcing the component. Okay, so the first steam is passed through the calandria. So here the calandria indicates the term heating element. Okay, or we can call it as a steam jacket. Okay, where we are going to pass the heat. So the steam will be passed through the calandria, the calandria will get heated, and we will be passing the pump with a velocity of 2 to 5 meter per second, the liquid which is going to concentrate. Okay, but that liquid will be forced by the pump through the tubes. Okay, when that liquid will be contacted with the calandria, the liquid starts to boil. The liquid starts to boil only, but it will not reach its boiling point. That the phenomena we call as a boiling point elevation. Okay, so your liquid will starts to boil with a high, because we are sending the liquid with a high pressure through the pump, but it will not reach the boiling point. Okay, and it will be come outside the tube with a high pressure. Your liquid and your vapor will get burst out from the tube, will get come out from the tube with a high pressure, and it will be touched with your deflector where the pressure will reduced down. Okay, it will come with high pressure from the tube, will touch the deflector, and the pressure will be reduced. After the coming from the tube, the pressure will be reduced, and the work of the deflector is to remove or is to separate your vapor as well as the liquid. Okay, the deflector will separate your vapor as well as the liquid, and the vapor will be sent to the cyclone separator where your solid particles or if you have some impurities, it will be get separated from the cyclone separator, and the vapor will be leaving from the cyclone separator, and remaining you will be having the liquid. Okay, so if you want to increase the concentration again, we can circulate among the return pipe. From the return pipe, the liquid will flow down, and it will be sent again to the pump, and the same process will be recycled. Okay, but this process will not be happen in the natural circulation. We will be having only one intake and a one outtake, but here we will be having, see, we will be having first the concentration of the liquid will be get increased, and then again it will be circulated. The more the concentration will get also increased. Okay, and your product will be, the product of the evaporator will be thick liquid, the liquid which will be having the high concentration or the thick concentration, and that will be collected from the bottom of your tank. Okay, so this is a simple working of the forced circulation evaporator. And coming to the advantage and disadvantages, so as we discuss about in working that this is forced circulation evaporator, so we can use the non highly viscous liquid. When you go for the natural circulation evaporator, the main drawback of the natural circulation will be the highly viscous liquid, because we will not giving any force to enter the liquid to the tube, but here we are giving the pump. So the main advantage of this evaporator will be we can go for highly viscous liquid. Okay, and the next one will be higher velocity. As I told you that it will contain 2 to 5 meter per second of the velocity. So the formation of the scaling will be very less. So how will you define your scaling? Suppose if your liquid contains some salt particles, or if your liquid contains some impurities, what happens after the evaporation? Okay, what happens? All the solid particles or salt particle will get deposited at the surface of the walls of the uh, equipment, okay, or side surface or bottom surface. But here we are having the higher velocity, that's why there is no possible of the formation of the scale. Okay, then the heat transfer rate will be automatically high. Okay, then we can use this evaporator for the foaming liquid oxide. The foaming indicates that which liquid will get your foam. Okay, that can be used in the forced circulation evaporator. But all these are essential parts, so we will be having an extra part cyclone separator and pump. Due to this, these have the drawbacks, like this is most expensive equipment. Okay, automatically will be having a pump and a cyclone separator, so automatically the maintenance cost will be high. Okay, and will be having high operating cost. High operating cost indicates that your electricity bill or your maintenance cost, everything, it becomes your cost effectiveness. So it will be somewhat costly compared to the natural circulation evaporator. Thank you. If you like this video, share it, subscribe it, and keep supporting to our videos. Thank you.